Okay, you should have your notes out that look somewhat like this, and we're going to do a brief introduction to piecewise functions. In the first quadrant, I need you to write the word definition, and then characteristics, example, and non-example. The definition of a piecewise function is at least two different rules that apply to different parts of the domain. And remember, the domain is your x value. So we're talking about two functions, one for one set of x values and another for a different set of x values. Some characteristics of piecewise functions are that they are varied rates of change, meaning that one set of your domain may have one slope, but the next is going to have a different slope. So you have varied slopes. We're going to use function notation, which instead of using y, we are now going to use f of x, and that's how this is. This f parenthesis x close parenthesis is pronounced. It's f of x. Okay, that's called function notation. And then we're going to use a bracket, and just one bracket. We're not going to use the closed bracket, but this shows all expressions in a group are part of that function. So it shows you that they all show up on the same graph and table, things like that. So an example would look like f of x equals, and then you have a rather large bracket because we're going to have more than one expression here. So the first expression is 2x plus 10, and this right here tells us when 0 is less than x and when x is less than 5. So between 0 and 5 for your x values, you're going to have 2x plus 10. Now from 5 to 10, it changes and it becomes 4x. And a non-example would be quadratic functions and cubic functions, because those are non-linear functions, and so are piecewise functions somewhat, but there's only one expression used to get those functions, while piecewise functions require more than one expression. And that's your brief introduction to piecewise functions. Make sure you have it all written down and you're ready to start practicing this.